No worries. All right, so for today, we are talking about SOHCAHTOA, okay? Again, everyone should have this drilled into their brain. What this means, this is just an acronym to represent what we are going to do with sine, cosine, and tangent, which are all trig functions. Okay, so if you heard of trigonometry, that's what we're talking about today. It sounds complicated. What we're doing today is going to be pretty straightforward, pretty simple. So repeat these after me. Sine, it's spelled, if you see the whole word, it's spelled S-I-N-E. We abbreviate it S-I-N. We do not say sin, we say sine. I will correct you if you say sin. It is sine, okay? Cosine, C-O-S-I-N-E. We abbreviate it C-O-S, cos. Don't say cos, it's cosine. And tangent, spelled like it sounds, we just abbreviate it tan. Okay? So sine, cosine, and tangent, we write them S-I-N, C-O-S, and T-A-N. So that is where we get the S, the C, and the T from. Where did they come from? What do those other letters represent? Well, when we are using sine, cosine, and tangent, we are talking about triangles, and in particular, right triangles. So if here's my right triangle, if you were to take a guess, what does H stand for on a right triangle? The hypotenuse, exactly. Okay. Now, we have the O and the A, and those are a little bit more confusing, a little bit easier to mix up. What that means is we pick one of those two other angles, not a right angle, but pick one of the other two. If I pick this one, I call that angle A right here. O stands for the leg of the triangle that is opposite that angle. And A stands for the side that is adjacent to that angle. What does adjacent mean? We don't use the word very often. If you remember from the video, what's adjacent mean? It's like next to. It's like me and Vanessa are like adjacent to each other. We're side by side. So look at that angle. We know it's not our hypotenuse, that's H. So the side that's adjacent is the one that's sharing a side with that angle. That's the adjacent one. What your opposite and adjacent sides are do depend on which angle you're looking at. Okay? So what we're going to use sine, cosine, and tangent for is we can set up ratios of the sides and compare that to the angle. So for example, if I am finding the sine of this angle A here, if I plug in sine of a number, for example, sine of 10, if you plug that into your calculator, which we will do, it will spit out a number. Okay? What it's saying that that number is going to be equal to the ratio of the opposite side over the hypotenuse. That's where the O and the H come from. So it's opposite over hypotenuse. So cosine, C-A-H, the cosine of A is equal to the adjacent side over the hypotenuse. And the tangent is equal to the opposite side over the adjacent side. Right? So again, this will depend on which angle you have picked. Looking at your triangle, you can always set up these ratios. So remember, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You have to memorize this. This won't be given to you on test. You must know SOHCAHTOA in order to set up these ratios. Right? Questions over this so far? Right, let's look at the checkpoint. I'm going to work through them with you today. Okay. And number one, find the cosine of angle A. So here's angle A. I'm going to circle it so I know which angle I'm looking at. And how do I know how to set up the ratio for cosine? Think. SOHCAHTOA. C-A-H. So what am I going to set up for my ratio? How do I spell ka? SOHCAHTOA. If you don't know, write it on your paper. SOHCAHTOA. So for cosine, yes, I look at adjacent over hypotenuse, A-H. I abbreviate. I'm not going to write out adjacent and hypotenuse every single time. But adjacent over hypotenuse. Which side is adjacent to angle A? What's the measure? It's 8. It's the one that's sharing a side of the angle that's not, they have hypotenuse. So we're going to do 8 over the length of our hypotenuse, which is 17. So if I plugged in, if I knew the measure of angle A, and I plugged in cosine of whatever that angle was, it should give me the ratio that's equal to 8 over 17. That's what this means. Let's look at another example. Number 2, find the sine of angle B. So first, mark angle B. Angle B is right here. Okay, for sine, what am I going to use for my ratio? Look at SOHCAHTOA. What letters? It's SOH. So for sine, I'm going to do opposite side over the hypotenuse. So the opposite side of angle B, I look at the side that's not touching the angle. That's 5. And my hypotenuse is 8. So the sine of B is going to be 5 over 8. It's going to be that ratio of the sides every time. Questions on number 1 or number 2? I get confused because I use 15 instead. Okay. On number 1, is that 15 sharing a side with angle A? No. So that is a good point. You need to make sure you know how to tell the difference between the side that's opposite the angle and the side that's adjacent the angle. If you are confused about that, you need to ask questions about that today. Make sure that you understand what's the side that's opposite and what's the side that's adjacent. Then also make sure you're looking at the right angle every time, because otherwise it will mix up your answers. Other questions on numbers 1 and 2? Alrighty, I'm going to skip the rest of the checkpoints and move on to the classwork for today, because they are similar. So, skip numbers 1, 2, and 3. Go to number 4, 5, and 6.
Real quick,
sure. Oh, yes. We're on 10, 4, 5. Alright, so looking here at number 4, we want to find the sine, the cosine, and the tangent. Hello, welcome. Drew, if you want, there's a packet. The blue packets are in that first bin.
Alright.
Alright, so number 4, we are asked to find the sine, cosine, and tangents. We're going to do all of these of angle A, not of tan B. I don't know why that's like that. Change that to A. We're going to find the sine, the cosine, and the tangent of angle A. So looking at angle A, I'm going to mark my angle first. It's this one right here. So for sine, what's that long word that we have to remember? Say it. SOHCAHTOA. There you go. Write it down. SOHCAHTOA. On every worksheet that we do from now on, you should write this word in big letters across the top. This is your point of reference. Okay, so for sine of A, we're going to do SOH. S-O-H. So we're going to do opposite over hypotenuse, which in this triangle, if I look at what's opposite angle A, it's 40. 40, this side that's 40, doesn't share any sides with the angle. And the hypotenuse is 41. For the cosine of angle A, I do adjacent over hypotenuse for C-A-H. So the adjacent side to angle A is 9. And my hypotenuse again is 41. And the tangent of angle A, again I just write that tan A, is the ratio of TOA, the opposite side over the adjacent side. So the opposite side we said was 40, and the adjacent side is 9. So you should get 3 different ratios for the sine, cosine, and tangent of that angle A. in this triangle, since all the sides are different lengths. Okay. Questions on number 4? Right. Do you feel comfortable finding which side is opposite and which side is adjacent? I would draw the picture for the opposite. Draw the arrow going across to the opposite side. All right. Let's look at example number 6. We're going to skip ahead. Example number 6 asks us to find the cosine of A. What ratio are we going to use for the cosine of A? Everyone should be able to tell me. Kellen, what ratio are we going to set up for the cosine of A? What do we do? Look at, what do we have for cosine? Look at SOHCAHTOA. What are the letters there after C? A and H. We have CA, C-A-H. So Kellen, what is the side that is adjacent to angle A? Looking at the triangle in number 6, we're looking at angle A. What side is adjacent to angle A? No idea. Okay, is 5 adjacent to angle A, or is 5 the hypotenuse? It's the hypotenuse. Okay, look at the side that's length 3. Is that adjacent to angle A, or is it opposite of angle A? Look at the triangle. It's on your page. Kellen, could you draw a line going from angle A to the side that's measure 3? Look at the triangle. Would you say that that angle is opposite that line, or are they touching? Yes. Looking at A and at 3.
4. I have no idea.
Okay, then you need to make sure that you're studying and doing your notes. Okay. All right. Gabe, is angle A and the side that is labeled 3, are they opposite from each other, or are they touching? They're opposite from each other. We can draw a line going from that angle to that side. It doesn't share the same side as the angle. So 3 is opposite. So do we know what our adjacent side is in this triangle? Is it given to us? No, it's just line down here that we don't know what the side is. So what do you think we can do to find that side, since we have to do Pythagorean theorem? We have a right triangle. So to find the adjacent side here, we can do the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. However, am I going to do 5 squared plus 3 squared? Why not? 5 is the hypotenuse. That has to go in for c. So I'm going to do 3 squared plus b squared, where b is what I'm trying to find, equals 5 squared. If I square those, I get 9 plus b squared equals 5 squared, which is 25. I want to subtract 9. Okay, from both sides, that will give me b squared equals 25 minus 9 is 16. So what does b have to be? 4. 4 squared is 16, so b equals 4. So we have our adjacent side now, so we can plug this in. The adjacent side is 4, and the hypotenuse is 5. So the cosine of A is the ratio 4 over 5. Right? Don't forget what you already know. If you're given a right triangle and you don't know what one of the sides is, you can find it. You guys know how to do that. Right? Other questions on numbers 4 or 6? We skipped number 5. We can go back to it if you guys want another example, but we are doing the same thing every time. We're setting up the ratios. Right? Okay, before we go on, we are going to